Here we are at example 6, looking at the real world. Now, when we're talking about these linear inequalities, we have a prime example where the SAT is actually scored on a system that's a little bit different than most exams. For every problem that you get correct, you actually get a point, and for every answer that you answer incorrectly, you're actually docked a fourth of a point. Okay, so it's a little bit different than typical exams, maybe like where if you get something right, you get a point, versus if you didn't get it right, you're docked a point. It works on a 1/4 deduction if you get it wrong. Now, the other like little bit of a trick behind it too is the fact that with the SAT, if you don't answer a question at all, you're actually not penalized. All right, you're not penalized. However, you're also not, you're kind of missing some potential points there. So it's not in your best interest to necessarily skip all of them or skip many of them either. Now, our goal here is to try and figure out what is an inequality that describes some of the possible different combinations of correct and incorrect answers that are available. Well, let's go ahead and let C be the number of correct answered ones. Then we're also going to let W be the number of wrong answered types. Now, for every one that we get correct, we know that we get 1 point. And for all those that we get wrong, we are docked a fourth of a point. And as a result, because we're docked, we're going to have a negative for this. Because again, it's being deducted. And in the end, we should end up with some kind of score. So our score is based on however many we get correct times 1 minus however many we get wrong times a fourth. And this would yield you your score. Now, our goal is to try and get at least 47 points. So as a result, instead of our score, we would just simply replace that with a 47 is equal to 1 times C minus 1/4 W. And if we wanted this to in fact be true, we want at least a 47. So this is the smallest thing that we can actually get. And as a result, with all of the number that we get correct and wrong, even though we're docked a fourth, all of this side on the right side has to be larger than a 47. Again, just because we need a minimum of a 47. Now, you could also write this as 1C minus 1/4 W is larger than or equal to 47. These two actually mean the exact same thing. So if this is a little bit easier for you to see, by all means use that. So here would be that inequality for all of the answers that are acceptable, where she gets at least a 47. Now suppose that Sarah answered 26 problems correctly, 16 problems incorrectly, and left 18 unanswered. Did she score enough? Well, pretty much all we have to do is take the number that she got correct, 26, throw it in for C. Take the number that were incorrect, 16, throw them in for W. The 18 is actually factored into the exam and with the amount of points that she's looking for. So for our 18, we don't even really have to have him at all. Now when we're looking at our inequality, we then end up with 1C minus 1/4 W. Is that larger than or equal to 47? Well, we have 1 times 26 minus 1/4 times 16. Is that larger than or equal to 47? Well, this just simply comes out to be 26 minus 4 is larger than or equal to 47. And as a result, it looks like we only get 22, which is clearly not larger than or equal to 47. And as a result, she did not earn enough points. So maybe what she needs to do is either answer more of these questions that were unanswered or get some of these more correctly. All right, so there are a couple of different options that she has. I would probably suggest that she looks at these problems, these 18 unanswered ones, and maybe shoot for more of those. Again, just because of a strategy, even if you're getting 16 wrong, you're only docked a quarter of them. So the strategy then would be look for these 18 ones that you haven't answered. Try and get some of those points. But again, though, that is example 6 from our 2.8 set of notes.